example?
5 minutes.
Yes, exactly. That is 5 minutes, right? Okay. Then the other one is you might want to make certain decisions. You might want to calculate the probability of no customers in the system, right? So there is a formula. We will be talking about that. So what is the probability of having no customers in the system, right? The system is idle. It's not working at all. So no customers are there, either waiting or being served, right? Then the probability of n number of customers in the system, it's like what is the probability of coming, I would say, 5 customers in the system within 1 hour. So something like that. So we might have to calculate something like that. For that, we can use that particular formula. So we will be talking about all those things later. Then the other one is this is called rho. The sign is, if I'm not mistaken, this is rho. Utilization rate, the proportion of the time the system is in use, right? So if it's like within 1 hour, uh, I mean for per hour we have 60 minutes. Out of those 60 minutes, how many minutes the system was active? It's like it might be again customers waiting time and being served. So altogether, what is the rate of this? The system was active. So it is known as rho. Again, for even for that we have a formula. So we will be talking about that later. Got it?
Yes, madam.
Right. So we will be like calculating these as average values, right? So we will be getting average values. So you will get to know about those things. Then waiting time is actually we cannot avoid it. It's associated with many business organizations. So since it is unavoidable, we have to take certain measures or certain actions to retain customers with us, right? Or we have to ensure that our customers are not uh, bored during their waiting or to get our service or something like that, right? So there's a concept called psychology of waiting, right? So now, for example, if you go to a hospital and if you or it might be a salon, even a salon, if you go to a salon, if that salon is well planned according to the service concept and everything, right? uh, if they have customers waiting to get their service, or if a customer arrived before the appointment time, still they might be having a very nice seating area. They might have set up a television, or they might be providing you free Wi-Fi and magazines and everything. So it's like psychologically you are trying to forget your customers. uh, they are waiting, all right? So like that, in many organizations they have taken or they take many measures to uh, avoid their customers feeling bored during their waiting, right? So so I would read, in some instances it is not possible to reduce waiting times, or important other important issues besides cost may be involved. When these situations occur, the problem of providing quality service often depends more on psychological solutions, right? So since this, as I told you earlier, we can't reduce these waiting times, so service quality is ensured by providing the psychological solutions, right? So, in other words, the organizations will try to make waiting more palatable, right? For example, long lines are fairly common at Disney World or uh, in popular theme parks. If you want to attend a certain event or an activity, there might be queues, right? So at that sort of a situation, now at Disney World, they say yes, this is possible. So although it is unlikely that any company has analyzed the technical aspect of waiting more than Disney, uh, customers must still wait for a long periods of time at certain shows, exhibits, and rides. Given the limited physical capacity of some attractions, the time required for a customer to complete them, and the large flow of customers, it is simply not possible to make the line shorter or the service quicker without letting fewer people into the park, right? So, again, don't worry. Now, in this case, in Disney World, there might be waiting lines because when it comes to, for example, if we say, I'm sorry, I have not been to Disney World, but I have been to some other theme parks. So, say if it's a roller coaster and per one ride, if they can cater maybe 20 customers, right? The capacity is limited to 20, right? And there might be more customers waiting due to this uh, capacity limitations. So that sort of situations are there. So that is the idea behind that. So when we have that sort of situations in in theme park situations, what they do is in Disney, uh, some costume characters, it might be Mickey Mouse or whatever the Disney cartoon based characteristics, characters, they might be, or some people, they get dressed like them and they distract the customers. So they pay their attention to those maybe mini shows or something like that, and they forget that they are in the queue, right? So, was it clear?
Yes, madam.
Then sometimes there might be mobile vendors, they are selling foods and drink and whatever the things, and there might be mini shops. So during your waiting, you can, if you want, you can go and buy certain stuff. So that sort of things are there. So yeah, that is the basic idea. Then waiting rooms, such as at doctor's office, provide magazines, newspapers for customers to read while waiting. Televisions are occasionally available in auto repair waiting areas, in airport terminals, or in bars or lounges of restaurants where customers wait, right? So you have experienced those things. And also, when it comes to um, uh, maybe the elevators or the lifts, mirrors are purposely located to distract the people while they wait. Now, from in elevators, if it's like we would say it's if it's like a 30-story building, if you want to go to the 30th floor, so it will take some time. So to distract, they might have set mirrors or something like that. That is the idea. So some service companies attempt to handle customer arrival in a smarter way by providing selective preferential treatment to a certain types of customers in order to reduce their waiting time, right? For example, grocery stores have express lanes for customers with only a few purchases. So you have witnessed that even in Cargill or Keels, they have like customers who are having like maybe up to 5 items. They can use that uh, checkout and get the service quicker, right? So it's a smarter way. Then airlines and car rental agencies issue special cards to frequent use customers or customers who pay an additional fee that allows them to join special waiting line at their check-in counters. Now, uh, if you don't like to wait, or if customers request, like, they can't wait in queues unnecessarily, so they might have or as service organizations, you can introduce special packages for your, maybe for your loyalty customers, or those who are okay, or those who are willing to pay an extra fee for that, right? Then online retailers check a customer sales history and route the call or inquiry to more experienced or specialized customer service reps. For some critical service providers, waiting times of any duration are simply not allowable, right? For a police or fire department must provide sufficient service capacity so that calls for assistance can have quick response. Now, for example, police or fire department, I don't know, sometimes that happens. Uh, Even hospitals, for emergency services, they can't have actually the waiting time. Those things are actually immediate or actually urgent cases. So at that sort of a situation, you should try to avoid waiting time, right? uh, so you have to maintain your sufficient capacity, but sometimes in the long run, if they might, those capacities might be underutilized, uh, and as a result, sometimes uh, cost might be increased, right? So that is the idea. Got it?
Yes, madam, got it.
Here, to avoid the waiting time, sometimes experienced service providers can be used. Like, you might have experienced in Cargills or Keys, there are some cashiers who do their job quickly, but some cashiers, trainees, they take extra time than an average or efficient cashier, right? So if you want to avoid waiting time, that sort of things can be done, or you can come up with proper training programs when it comes to the servers, right? Then here we can see a single server waiting line. That means there is one server, and this is single server. It might be single phase as well. Here multiple servers or multiple channels, right? And again, this might be single phase as well, right? Uh, So waiting line models, the basic single server model, in the basic single server model, we assume the following. Now, when it comes to calculations, here we assume we are talking about single channel, single phase or single server model, right? So the basic single server model, we assume the following. Now, from this point onwards, we might be doing some calculations. So listen carefully, right? So in a single server model, customer arrival rate, I think I talked about this last week as well. Arrival rate, we say it has a Poisson distribution or Poisson arrival rate, right? Then the service rate or the service time, it has an exponential distribution, right? Then we assume first come, first served queue discipline. The customers who come first, they are served first, right? Then the queue length is infinite, and the calling population is also infinite, right? We don't have any limitations like per hour we will be serving this many or something like that, right? So these are the assumptions. So a single server model, we are going to compute mean arrival rate, or we denoted it as, I don't remember this term now. Lambda. Yeah, this was lambda. Then the mean service rate, it was mu, right? Then the number of customers in the waiting line system, including the customers being served, is known as n, right? The probability that no customers are in the queuing system is calculated using this, right? So if you want to calculate now, simply I would be focusing on this. If you want to calculate probability that no customers are in the queuing system means not in the queue or being served. For that, the formula is P0 equals 1 minus lambda, or mean arrival rate, divided by mean service rate. Is it clear? It's like 1 minus lambda, that means mean arrival rate divided by mean service rate. Clear? Was it clear?
Yes, madam.
Right. Then the probability of exactly n customers in the queuing system, there n means probability of 10 customers in the system. It might be 2 customers in the system, 1 customer in the system, or something like that, right? So for that, the formula is this, right? This is the basic formula, and this is the expansion of it, right? Now here, probability of having n customers in the system, lambda divided by mu, or average arrival rate divided by average service rate, to the power n, that particular answer multiplied by probability of having 0 customers in the system, right? So this is the expansion of this. By now you know this is the probability of having 0 customers in the system, right? Clear?
Yes, ma'am.
Yes,
Was it clear?
Yes, ma'am.
Clear or not clear?
yes, madam. Clear.
Right. The average number of customers in the queuing system, right? For that, again, average number of customers in the queuing system, that means customers being served and in the waiting line. Oh, sorry. Right? So that is denoted by L. So how are we going to derive it? Lambda, or average arrival rate, divided by average service time minus, average service rate minus average arrival rate, right? Then the average number of customers in the waiting line, that is LQ, lambda to the power 2 divided by mu into mu minus lambda. Then average time a customer spends in the queuing system, entire system, that means the waiting time and the being served, that is known as W. That is, there are 2 formulas that you can use. One is 1 divided by mu minus lambda, or L divided by lambda. So L means this, average number of customers in the system. Don't worry for the exam. If you are going to if you are tested on these things, formula will be provided, right? So the next one is average time a customer spends waiting in the line to be served, right? That is known as YQ, that is lambda divided by mu mu into mu minus lambda. Then the probability that the server is busy and a customer has to wait, known as utilization rate, that is lambda divided by mu. Right? This is average time customer spends in the entire queue system waiting and the being served. This is average time a customer spends in the waiting line to be served without serving time. Right? So those are the formulas. Right? Then there's another one, probability that the service idle or has no customers. That is I equals 1 minus rho. Or there's another one, or probability of having 0 customer. I is equal to probability having 0 customer as well, right? Here. Was it clear? This is I equals to, the conclusion is probability having 0 customer. When the line is idle, that means probability of having 0 customers. Can calculate it by 1 minus rho or 1 minus this, or rho equals to this, similar thing, right? Clear?
Clear, ma'am.
Right. Then these operating characteristics are actually averages, right? So we cover this over a period of time, and sometimes you might feel customers cannot be 3.2 or something like that. That is because of the averages we are doing, so right? So that is the simple idea, right? So based on the formulas that we discussed, now we can do the calculations, right? So the auxiliary bookstore in the student center at Tech is a small facility that sells school supplies and snacks. It has one checkout counter where one employee operates the cash register. The cash register operator represents the server in this waiting line system, right? The server is the register and operator, right? The customers who line up at the counter to pay for their selection form the waiting line, right? So customers arrive at a rate of 24 per hour according to a Poisson distribution, or that lambda is 24. Service times are exponentially distributed with a mean rate of 30 customers per hour. That means mu is 30. The bookstore manager wants to determine the operating characteristics for this waiting line system, right? Uh, right. So now we can calculate certain things, right? So we'll do that. You give it a try. I'm preparing the Excel sheet. Okay, I'm going to share the screen now. Can you see an Excel?
Yes, madam.
Yeah. So you are given lambdas or the average arrival rate. It is 24. Average serving time is 30, right? So those things are given. Now, can you find the probability of having 0 customers in the system or P note? So how are we going to do that? 1 minus lambda. Lambda means average arrival rate divided by average serving time. Right? It is 0.2.
True.
Got it?
Yes, yes, yes.
Then having, I would say, having 2 customers in the system. Probability of having 2 customers in the system, P2, right? Or probability of having 2 customers. Sorry, probability of arriving 2 customers. Yeah, having 2 customers in the system, right? So how to calculate it? How to do that? The formula is lambda 24 divided by mu 30, right, to the power n. That means here n is 2. So to the power n means 2, right? So multiply this entire answer by PO or P note. That was 0.2. Clear? Then it's 0.128. Can everybody understand this? If not, please tell me. Cannot? Can't understand? Dr. Kumutini, can you understand?
Yes, madam.
Yes?
Yes, madam.
Right. Then average number of customers in the queuing system. So that is including waiting and the being served. So the formula is L. So L, how are we going to get it? Lambda, that is again 24 divided by mu minus lambda. Mu is 30, 24. So that is 4 customers are average on average 4 customers are there in the queuing system. Then average number of customers in the waiting line, that is, now I'm going to give you another question to do it by yourself within the class. So LQ is lambda to the power 2, right? That means lambda was 24, 24 to the power 2 divided by mu, that is 30, 30 minus lambda again 24, close the bracket. It's 3.2. Clear? So that is like average number of customers in the waiting line, right? Then we have W, the average time a customer spends in the queuing system, that is waiting time and the being served time. For that, you can use this L divided by mu. L was 4, W equals L was 4 divide L divided by lambda, sorry, not mu. It's 24, right? Uh, If you want, you can convert that to minutes by multiplying this answer by 60, right? So you can do that if you want. Then average time a customer spends waiting in line to be served, right? That is WQ. So WQ is lambda 24 divided by 30. Yep. Into 30 minus 20. It is 1.33. Now if you multiply it by 60 minutes, you can take it as 8. So to get the service, they and on average customer has to spend 8 minutes, right? So that is the idea. Then the probability that the service is busy and a customer has to wait, known as the utilization factor. That means like how how busy the service is, how much the service or the server is busy. That is calculated as rho. Rho means 24 divided by 30. That is 8.8 or 80%. Server is busy around 80%, right? So customer might have to wait like for 20%. That is the simple idea, right? Then the probability that the server is idle, that is I 1 minus rho. Rho was 0.8. That is 0.2. Right? Okay, got it? Was it clear? Or not clear? Clear or not clear? Tell me, please. Wasn't that clear?
Madam,
Yes.
Madam, which means when the 10 customers are waiting at the line, 2 are served, rest of the 8 are waiting. Like that?
Mm, Let me share that and answer your question. Where? Which one are you asking? Here? Referring to which question you asked that? I didn't get you, that's why. Could you please ask that question again? I'm sorry, who asked that question? That's fine to ask that again.
Madam, ultimately, the example reveals when there is 10 customers are waiting at the queue, two only served by the system. Rest of the 8 is waiting.
Yeah, it's something like that, yes.
Okay, ma'am. Thank you.
Yeah, you're correct, yes. But with respect to time, if you take like here, average time the customer spends in the queuing system, if it's 10, now once you enter the service center and until you get your service, you have to spend 10 minutes. But to get your particular service, if the average time a customer spends in the waiting line, that means you have to wait for 8 minutes, but your service line to be served, yeah, your service will be served within 2 minutes, something like that. Clear?
Okay, madam.
Yes, ma'am.
Right. Now I'm giving you this question. You have to do it by yourself and share the answers with me. I'll give you like 10 minutes to work on this. Everyone has to do. So, rate of arrival, that is lambda, rate of service, that is mu. Exactly having one customer, that means for PN, I'm asking this. The other characteristics, those would be the same. Are you okay with that? Are you done? What was probability of having 0 customers in the system? Did anybody calculate it? Please talk.
0.34.
Yeah, so how did you
Point
calculate?
3, madam.
1 minus
10
rather it is
divided
1
10.
minus
10 divided 15.
Yeah,
10 upon 50.
0.33. Yeah. Then arrival of one customer. It's how did you calculate this? Arrival rate 10, service start rate 15 to the power 1. Not into that,
0.34.
but then this 0 point. Okay, I'll
2.
2, right? Correct. Okay. Okay. Then this one L is like having customers in the system. Average number of customers in the system. Yep. L, how to calculate it? Lambda.
Lambda square.
Lambda was
10.
10, right?
Yes.
10 divided by mu minus
8.
lambda.
1.3.
Sorry, mu minus
1.3.
wasn't that 2?
1.3.
Lambda is 10. Arrival rate is 15. 10 divided by 15 minus lambda. So that is 15 minus 10, it's 5. 10 divided by 5, it's 2. All right. Then LQ, average number of customers in the waiting line. That is lambda to the power 2. That means 10 to the power 2
by
divided by
mu
mu 15 minus lambda,
10.
right?
10. 1.3. Okay.
Correct, right? You got 1.33.
1.3.
Yes.
Yeah. Then this is 1 divided by mu minus lambda. 1 divided by mu is 15, lambda is 10. 0.2, if you want, you can multiply this
Point.
by 60. Then WQ is lambda.
0.
Then again mu, right? 15 minus 1.33.
0.13.
Right?
0.1.
0.13.
Yeah, 0.13. Yeah.
0.13. Okay.
You got that same answer, right? Then probability of service busy or row, that is 10 divided by 50, 6, right? I means 1 minus that. Okay, got it? 0.33, yes. Right. So for the exam, there might be questions from this. Sometimes you might have, not all the time, that might not be, direct. Sometimes you might have to think of certain things. I'm not so sure yet. We'll see how it goes. You better to refer to the past paper and have an idea, right? So with that, we can wind up this chapter 3. Then we are going to start chapter 4, process design. Did you get this slide?
Yes, ma'am.
Right. Next week I won't be able to do the session, maybe week after next. I have informed it. We'll see how the arrangement would be. Right. Now, the chapter 4 is all about the process design. Under chapter 3, we talked about how a service is designed or a product is designed. So, when it comes to designing a product or a service, we have to think about the process as well. So, we talked about that as well under product designing. We talked about the production design or production, whatever the specifications. Even with the service, we talked about delivery specifications or something like that. So, again, for any organization, if it's going to be either a manufacturing organization or a service organization, they have to think about the process design as well. Sometimes, based on the process, sometimes we have to change the product or the service, or else based on the product or the service, sometimes we have to change the process. So those two are actually interlinked. So it depends on the organization's objectives and many other aspects. It might be the technology, finance, and everything, skills and all. Based on that, they will decide what is to change, right? So that is the basic idea. So in this chapter, we will be talking about operations, processes, characteristics, process design versus service or product design. I think I talked about that almost. Then process design objectives, process types, detailed process design, and we are going to talk about the break even analysis, right? So when it comes to operations, processes, process characteristics, it says although all operations are similar, that they all transform input resources into output products or services, they do differ in number of ways, right? So if you can remember, in operations in general, we talk in operations, what we do is input or input resources, those are transferred into output. It might be as a product or a service. But when it comes to these operations processes, they might be different based on different characteristics, right? It might be different based on the volume or how much uh, or how many products that you produce, right? Or how many customers are you going to serve, right? And also variety of their output, or are you going to produce one type of a product, or are you going to produce a standardized service or one type of a service, or are you going to produce products with different characteristics? For example, if it's going to be we would say what if it if it's going to be a food item, right? It might be rice. Are you going to provide fried rice only? Or, I mean, when it comes to fried rice, it might be chicken fried rice only. If so, you are like producing one type of a product. But if you are going to have variations such as goat fried rice, egg fried rice, vegetarian, chicken, beef, pork, or any other meat of different variations, that means you are producing a variety of products. So based on that, since you are going to produce a range of products, your process might be different, right? Then the other fact is variation in the demand for their output, right? So how would be the demand? Is it going to be stable throughout the year, right? When it comes to your fried rice production, we would say the demand, is it going to be we would say 20 customers every day, right? If so, it's a stable one. But it might be varied. Like during the weekend, the demand might be high, but weekdays demand might be low. So based on that, you might have to think, are you going to change the process during the weekend? Are you going to hire extra people or extra staff, or are you going to enhance your capacity in the kitchen or something like that, right? Then the other one is degree of visibility which customers have uh, of the production of product or service. Degree of visibility means, like, if you go to a shop, simply it might be a restaurant or a department store, a store or a clothes shop. So how, if you are going to maintain visibility as the service provider, that means you have to be very courtesy to your customer. You have to fulfill your customers all the requirement. The display of the outlet should be really attractive, so everything should be maintained. So there, if you are going to uh, enhance the visibility, yes, your process and process related whatever the facilities, you have to organize. But if you are going to maintain something offline, sorry, online, right, department store or a clothing shop, if you are going to maintain that online, then you do not have to have like many facilities, right? So likewise, based on different operations characteristics, your operations processes will be varied, right? Is the overview clear? Could you understand the overview or the basic idea?
Yes, ma'am.
So I'm just explaining them one by one, right? So the volume is the level or the rate of output from a process. So for example, high volume hamburger production in McDonald's serves millions of burgers around the world every day. Volume has important implications for the way McDonald's operations are organized, right? So repeatably, that means since they are or else I'll just read repeatability. That means the extent to which an activity does not vary, and the systemization, the extent to which the standard procedures are made explicit, can be seen with high volume production. So, with high volume production, that means you are producing one product in a large quantity, right? So as the operations team, you might be doing the same thing for several times. That is the idea behind this repeatability. Then therefore you might be you might be doing the same thing for so many times. So the extent to which an activity does not vary, right? You will be doing the same thing, no varied activities, right? Then the systemization is, since you are doing the same thing again and again, you are going to have like standardized procedures, right? That means like, this is the process of hamburger is assembled. This is the first step, this is the second step, this is the third step. So likewise, you might be having the procedures sometimes for uh, the burger patty. You might be having a certain recipe even for that, how to produce it. It might be having certain steps, so something like that, right? So systemization of the work, where standard procedures are set down in a manual with instructions on how each part of the job should be carried out, right? Set down, it might be written mostly. So this is how you do it. Further tasks are systemized and repeated. It is worthwhile developing a specialized fryers ovens. All this gives low unit cost, right? So when you have high volume to be produced, it's better to have specialized machines or the equipment, as well as specialized labor as well. So resultantly, your per unit cost will be reduced, right? Because sometimes when you have specialized machines to produce a larger quantity, in the long run, you will be having economies of scale, right? That means when you are producing a large amount of items, uh, per hour production would be high. As a result, per unit cost would be reduced. When it comes to specialized workers, they are engaging in the same activity for a longer period of time. As a result, per unit, sorry, per hour output would output of them would be high, and resultantly productivity would be high, and at the end per unit cost would be reduced. So that is the basic idea. Then, compared to this large scale organization, if you talk about a small local cafeteria serving a few short order dishes, the range of items on the menu may be similar to the large operation, but the volume will be lower, right? Therefore, the degree of repetition will also be lower. Now, when you have like McDonald's, they might be having per day, assume they might be taking 1,000 orders, but the small organization, they might be taking 100 orders, right? So they will not be doing the same thing again and again frequently. They will be doing, but not frequently. Furthermore, the number of staff will be lower, possibly only one person, because the order quantity is low. Specialization is no point of having specialization, because the orders are really low. The volume that you produce is really low, so no point of having. Now, in McDonald's, they might be having a person who is frying chips. That person is for that. There might be another person to do something else. But here, in this particular organization, since the quantity of uh, production is really low, the same person would be doing all the activities, right? Therefore, individual staff are likely to perform wider range of tasks. This may be more rewarding for the staff, but less open to systemization. Also, it is less feasible to invest in specialized equipment, so it follows that the cost per burger served is likely to be higher, right? So they can't have specialized equipment as well, because when it comes to specialized equipment, sometimes the capacity of that them would be really high, and no point. And when it comes to this small local cafeteria, they might be serving not only with the burger, something else as well. Even for that, they should have a common purpose machine. So therefore, their per unit cost will be high compared to larger production. Is the idea clear simply?
Yes, madam.
Then the variety. That means the range of different products or the services produced by a process, right? Now, here you are given an example. It's like, now, when it comes to normal bus service or the public transportation, you cannot get a customized service, right? If you want from your home, if you want to go to, uh, we would say BMICH, right? So, from home, sometimes you might have to walk, it depends. Imagine you have to walk to a bus halt and hail a bus and take a ticket and pay that amount. It might be compared to tax services, the 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 cost would be very low, right? Then you have to get down, maybe if it's one bus directly to BMICH, you have to get down near BMICH and then you have to walk. The cost is low, but for you, uh, the you might be very tedious, right? Or you are not given a customized service. So their variety is not less. right? So a common service is provided to each and every customer. But when it comes to taxi service, right? A taxi company offers a high variety of service. It may confine its services to the transportation of people and their luggage, but it's prepared to pick you up from almost anywhere and drop you off almost anywhere, right? So if you take uh, maybe an Uber ride for the same purpose, you can book it online and taxi will be arrived at your doorstep. You have to get on. Sometimes that person might be using, if there is traffic, that person might be using an alternative route, and or as per the map, that person might be using the shortest route to the BMICH, and you can get down. Uh, I mean, in front of BMICH, not at the gate, somewhere closer to whatever the hole that you want to attend, right? So that is the nature of this customized service, but the fare, the charge would be really high, right? So drivers must have a good knowledge of, now when it comes to giving this variety of services or the products, the skill level of the worker should be very versatile, right? So driver must have a good knowledge of area, communication between base and the taxis must be effective. However, this does come at a price. The cost per kilometer travel will be higher for a taxi than for a less customized form of transportation, such as a bus service. So, as I told you, this is the difference. Was it clear?
Yes, madam.
Right. Then we are going to talk about the variation. Variation means the degree to which the rate or the level of output varies from a process over time. So, uh, as I told you, like when it comes to, it might be either production related activities or the service related activities. Variations are there, demand variations are there. So, based on that, we have to think how are we going to cater that, or how are we going to respond to that. Based on that, we have to design our processes. So consider the demand pattern for a successful summer holiday resort hotel. Not surprisingly, more customers want to stay in summer vacation times than the middle of winter, right? So at the height of the season, the hotel could possibly accommodate twice its capacity if it had the space. Off-season demand, however, could be small fraction of its capacity. That means, now this now when it comes to foreign countries, during the summer everyone is enjoying going out. The hotel, if a hotel is designed or planned to cater its visitors during summer, it has to be designed like that, right? So considering the summer demand, they have to design it, right? But when it comes to other seasons, the hotel will not be fully occupied. There might be unutilized capacity or unutilized rooms, and kitchen area might not be fully utilized or something like that might happen, right? So, such a marked variation in demand means that the operations must change its capacity in some ways. For example, by hiring extra staff for the summer. But in flexing its activities, the hotel must try to predict the likely level of demand. If it gets this wrong, it could result too much or too little capacity. Recruitment cost, overtime cost, and underutilization of its rooms all make for a relatively high cost per guest. Right now, here, as I told you, for summer you have uh, to predict the demand accurately. and design the hotel accordingly, right? If not, even if you have not done it properly, even for the peak season, you might be having either too much capacity or too little capacity. So during the off season, obviously, it will be underutilized. But if you have that sort of a situation, that is not a very good thing, right? If you have too little capacity, you are like uh, missing your customers, loyalty customers. If you have too much capacity, it's like unnecessary cost, right? So that sort of things are there that you have to consider. Then there's another scenario. All of these factors have the effect of increasing the hotel's costs operation compared with a hotel of a similar standard with level demand. That means level demand means it's like you are okay to cater now, you without considering the summer or any seasonal variations throughout the year. On average, you might be forecasting the demand, and based on that, you decide, okay, our service is going to cater for this many visitors any day throughout the year. So accordingly, you might be uh, planning your production or the service, right? So conversely, a hotel which has relatively level demand can plan its activities well in advance. Staff can be scheduled, food can be bought, and rooms can be cleaned in a routine, predictable manner. This results in a high utilization of resources. Not surprisingly, the unit cost of this hotel are likely to be lower than those hotels with high variable demand pattern. If you know, like constant or every day your customers are visiting as you plan, yes, your capacity is fully utilized, your employees are working all the or every day, and they become specialized in activities, so resultantly productivity will be high. So as the end outcome, the unit cost would be reduced, right? So this is with less variability, but with high variability, cost might be per unit cost might be somewhat high, right? So that is the idea. Clear? Was it
Yes.
clear? Right. Then the next one is uh, visibility, right? So the visibility is the amount of value-added activities that takes place in the presence, right, in reality or virtually, of the customers, also called customer contact. Right? Visibility means, is it a high customer contact or a low customer contact? Right? So high customer contact means, as I told you, if you go to a department store, it might be Cool Planet or any other shop in maybe a shopping mall or anywhere. If you go to that particular shop, yes, you have to ask maybe a sales girl or a sales boy whether this particular item is available, or is there any color of this particular thing. So likewise, you have to contact, right? And but when it comes to an online one, yes, still you might be contacting through maybe chats or any other way, but from the organization's perspective, uh, they might want, they might, I mean, they do not want to have many employees. They can be utilized maybe one or two employees who can handle this chatbots or something like that, right? So that sort of things are there, right? So visibility is slightly more difficult dimensions of operations to envisage. So it means how much of the operations activities its customers' experience or how much the operation is exposed to its customers, right? So generally, customer processing operations are more exposed to their customers than material or information processing operations, right? So this means, uh, as I told you again, if the high contact or customer services are there, of course, as the service organization, you have to contact with the customer. So you have to please the customer, you have to satisfy the customer, right? So that sort of things are there, right? But even customer processing operations have some choice as to how visible they wish their operations to be, right? So you have to decide like which activities are you going to make visible to your customers. As I told you, if it's going to be a coffee shop, are you going to make coffee making visible to customer or not? And if you're going to make it visible, you have to buy nice equipment, have to arrange kitchen nicely because that is pleasing the customer. So you have to decide all those things, right? For example, in clothes retailing, an organization could decide to operate as a chain of conventional shops. Alternatively, it could decide not to have any shops at all, but rather run an internet-based operation. So this is another example, right? If you are going to have a brick and mortar organization or an online one. So if bricks and mortar shop operation is high visibility operation in so much as its customers experience most of its value adding activities, right? Give me 1 second. One more thing, there was a request when it comes to assignments, you wanted that as individual assignment. Yes or no? Can you all hear me?
Individual assignment, madam.
Right. Okay. Yeah, that's fine. How many students are there?
Around 30.
Okay. That means marking time would be high for me, but that's fine if you can't manage it. Why do you say that you can't do a group assignment? You can't contact the people?
Yes, madam, that is very difficult because of we work in different areas. One part of the Colombo and other part of Jaffna. And yes, that is very difficult.
Okay. That's fine. Right. So back to the lesson. So we were talking about the visibility. The bricks and mortar shop operation is high visibility operation in so much as its customers experience most of its value adding activities. Customers in this type of operation have a relatively short waiting tolerance. They will walk out if not served in a reasonable time, right? So that's the most important thing. It might be either a production or a service organization. If you have to wait for so long as a customer and if you are not treated properly, nicely, if the courtesy is not maintained as a customer, you will you will not visit that particular organization again, or at that sort of at that very moment you may feel like, okay, we'll walk out and we'll go for another shop, something like that. Therefore, as service organizations, if you are going to serve your customers physically, or even as a production, no, not production, service organization, if you are going to physically serve your customers, you have to maintain, as per your expectations, you have to maintain the facility accordingly, right? Without making your customers disappointed, right? So they might also judge the operation by their perception of it rather than always by objective criteria. If they perceive that a member of the operation staff is discourteous, as I told you, to them, they are likely to be dissatisfied, even if the staff member meant not discourtesy. So high visibility operations require staff with good customer contact skills, right? Even though your service staff is very polite and nice, but if they can't understand what customers are asking, or if they can't provide what the customers want, again you are failed. Therefore, it's important to train your customer service or the staff and ensure all those things, right? Customers could also request goods which clearly would not be sold in such a shop, but because the customers are actually in the operation, they can ask what they like, right? So this is called high received variety and will visibility actually will occur even if the variety of service for which the operation is designed is low, right? So there, when you are going to design your operations, you have to be very careful, right? This does not make it easy for high visibility operations to achieve high productivity of resources, with the consequence that they tend to be relatively high cost operations. When you are going to make sure high visibility, you have to maintain lots of facilities. Sometimes you might have to have different outlets in different areas, more staff, more resources, so the cost would be high. That is the idea. And contrast to this bricks and mortar, if you are going to go online or the shop with an internet based clothes retailer, while not a pure low contact operation, it still has to communicate with its customers through its website. It has far low visibility, right? So customer contact, it means like, yes, you have to communicate, but when it comes to physical contact, you have to ensure the background is appealing and customers are not being in the waiting lines or disappointed, so everything. But when it comes to online, yes, you have to do that, but the physical appearance, it's just the website, no other brick and mortar, or just it might be just a warehouse or something like that, right? So behind its website, it can be more factory like. The time lag between the order being placed and the items ordered by the customer being retrieved or dispatched does not have to be minutes as in the shop, but can be hours or even days, right? So in a shop, if you go and buy a cloth, so yes, you can buy it within few minutes, or you have, as a salesperson, you have to respond to the customer within few minutes. But online, once you have ordered something, it will be delivered maybe to your doorstep, maybe within the same day or based on their delivery promised delivery period. So this allows the task of finding the items, packing and dispatching them to be standardized by organizing staff, which needs fewer customer contact skills, can achieve high staff utilization. So in this case, as I told you, to operate the website, you might want to have maybe one or two employees. Then to dispatching, you might be getting another service to pack them and all. You might be having one or two staff. They can handle everything, right? So that sort of things can be done. So the staff, they might be very productive. That sort of things are there, right? Then the internet-based organization can also centralize its operations on one physical site, whereas the brick and mortar shop needs many shops close to center of demand, right? As I told you, many shops can be there, right? For all these reasons, the internet operation will have lower cost than the shop, right? So when you, the essence is when you have low visibility, per unit cost will be low. High visibility, per unit cost will be high. Was it clear?
Yes, madam.
Right. Then here again the summary is there. When the volume is high, it means high repeatability like McDonald's, specialization, systemization, capital intensive, low unit cost. But when the volume is low, low repetition, each staff member perform more of job, many activities, less systemization, high unit cost. When the variety is low, that means you might be having one or two products. Those are well defined. You can have standardization, routine activities are there, regular activities are there, productivity is increased, resultantly low cost units. When the variety is high, that means the flexibility is there, complex. We have to customize, cost, we have to cater to customers' needs, and resultantly cost will be high. Variations in demand, when it's low, cost is low, but high, cost is high, right? Visibility, yes, when the visibility is high, short waiting tolerance, satisfaction governed by customer perception, customer contact skills needed, receive variety is high, and high unit cost. When the visibility is low, time lag between production and consumption, standardized, low contact skills, high staff utilization, centralization, and low unit cost. So this is the basic thing. Then we are going to talk about the relationship between process design and product or service design. I have already discussed. So from this Venn diagram, you can see designing the process and the designing the product and service, those two are overlapped, right? Products and services should be designed in such a way that they can be created effectively. Processes should be designed so often they can create all products and services which the operation is likely to introduce. But product and service design has an impact on the process design, vice versa. That means, as I told you at the beginning, when you design your product or service, based on that, sometimes you might have to change the process, or based on the process, considering that small changes of the product or the services can might have to do, right? Uh, so small changes in the design of the product and the services can have profound implications for the way the operation eventually has to produce them. Or similarly, design of the process can constrain the freedom of product or service designer to operate as they would wish. So if you are going to design the product or the service based on the operation, it might be a limitation some of the cases, because although you want to design a very innovative one, sometimes the system doesn't support, right? Was it clear? Was it clear? Yes or
Yes,
no?
madam.
Yes, madam. Yes.
Mm, you might hear someone is snoring. That's not a person, it's a dog here, right? I'm sorry about that. Then the whole point of process is to make sure that the performance of process, sorry, uh, Right. Now, we talked about performance objectives. Can you remember last week? Did we talk about something like that? What are the performance objectives? Can't you remember? Can't remember. Quality, cost, flexibility, time, right? So based on organizations' performance objectives, maybe based on the corporate strategy, in lining with whatever the performance objective, you might have to design your process. So that is the simple idea, right? For example, if an operation competes primarily on its ability to respond quickly to the customer request or customization, or they are actually responding quickly, it's like competing with the time. Its process need to be designed to give fast throughput times, right? This would minimize the time between customer requesting a product or service and them receiving it. Okay. Similarly, if an operation competes on low price, cost related objectives are likely to dominate its process design. So if you are going to focus on low cost, you have to focus on standardization, using specialized equipment, labor, specialization. So you have to focus on all those things, right? Then some kind of logic should link what the operation as whole is attempting to achieve and performance objective of its individual processors, right? Was it clear up to that point?
Yes, madam.
Right. Then we are going to talk about the process types, right? Uh, right. So process types, types means terms that are used to describe a particular general approach to managing processes. Now, don't worry, when it comes to service organizations and manufacturing organizations, based on the volume that they produce and the variety, basically, uh, we have theoretically categorized different process types, theoretically, right? So by observing the practical situations and everything, we have theoretically categorized certain process types. So we are going to talk about those process types now. So those process types are different from manufacturing to services, right? So in manufacturing, these are generally held to be project, jobbing, batch, mass, and continuous processes. In services, they are held to be professional services, service shops, and mass services. So low volume operations, that means the quantity that you produce is low, often have high variety of products and services, right? So that is some kind of a no, right? So when you produce I mean, if you are producing many products, it might be, let's say, again, as I told you, fried rice, you might be having various categories. From one category, you might be producing maybe a small amount, right? Then if you're going to produce high volume or quantity is high, the variety might be very low, right? So there are some shops, they say we are not providing a large variety. We have like one or two items, right? So the variety is very narrow, right? So based on this, actually, we have to categorize different processes. right? So when it comes to manufacturing processes, we have these types as shown in the slide. Then service processes, we have three, right? So again, that is linked with this variety and volume, whether it is high or low. So we are going to talk about first the manufacturing related process types. The first one is project process, right? So project processes are those which deal with discrete, usually high customized products, right? So now I'll use an example. When it comes to project processes, it might be actually the construction projects, right? So if you are going to develop a building, that is a project related process, right? So the time scale making the product or the service is relatively long. This should be actually product, not service. Is relatively long, as is the interval between the completion of each product. So the low volume, high variety are characteristics of the project processes. Now, when it comes to construction projects, they might be most of the time developing unique buildings, right? The activities involved in making the product can be ill-defined, uncertain, sometimes changing during the production process itself. That's obvious based on the customer's requirement. Sometimes the plan might be changed, and accordingly the development might be changed. Examples of the project processes include shipbuilding, most construction companies, movie production companies, large fabrication operations such as those manufacturing turbo generators and installation of computer systems, right? So simply remember them, right? Sometimes with respect to projects, uh, they might be using unique maybe skills and the unique machines or the equipment or items or the skill and the equipment they might be hiring or purchasing only for that project purpose, right? So you might have like heard or seen advertisements. They are hiring some sort of skills for projects. So those projects might be for a very short time, or maybe year for 1 year or 1.5 years or 2 years. So once the project is done, the job is lost. So equipment might also be uh, purchased for that particular project only. So that is one specialty. Then the next one is jobbing processes. Jobbing processes also deal with a very high variety and low volumes, right? Variety is high, volume is low. So a good example is for this one is a tailor, right? When it comes to a tailor for your unique requirement, uh, whatever the dress you want to have in color, in shape, and everything, that person might be done that for you, right? So that is a good example. Whereas in project processes, each product has resources devoted more or less exclusively to it. In jobbing processes, each product has to share the operations resources with many others. Now, the, the first part of this I explained. Then when it comes to jobbing processes, if you take a tailor using the same machine, he might be sewing different garments in different shapes, right? So that's what the idea behind this sharing the operations resources with many others. The resources of the operation will process a series of products, but although all the products will require the same kind of attention, each will differ in its exact needs, right? Examples of jobbing processes include many precision engineers, such as specialist tool makers, furniture restorers, bespoke tailors, the printer who produce tickets for local service event. Now, printing organization, yes, for their print, if it is going to be a very unique thing, ticket or a wedding card or something like that, that will be very unique, and using whatever the available machines, they will do that, right? So variety is high, the quantity will be really low. Then the job-in process produce more and usually smaller items than project processes, but like project processes, the degree of repetition is low, right? Small items in the sense size-wise, right? So many jobs will probably be one-offs. That means one-time production. Is it clear? Oh no.
Yes, madam. Yeah, madam.
Then we have batch processes. Batch processes can often look like job-in processes, but batch does not have quite the degree of variety associated with jobbing, right? Uh, I did not give you a break. Shall we take a 20-minute break?
Okay.
You have to
Okay.
be in 25, I would say. Okay.
Okay, madam.
Okay, I think we are back. Uh, okay, we were talking about the batch process. The batch processes can often look like jobbing processes. Now, when it comes to the jobbing processes, the tailor was an example. So one of products will be produced. It might be one or two pieces, lower volume, but the variety is very high. But batch does not have quite the degree of variety associated with jobbing. So customized products will, I won't say will not, like hardly be produced. So as the name implies, each time batch processes produce a product that produce more than one, right? So of course it's in a batch we might be producing a quite number of items. So each part of the operation has periods when it is repeating itself, at least while the batch is being processed. The size of the batch could be just two or three, in which case batch processes would differ little from jobbing, especially if each batch is totally novel product, right? So when it comes to batch processes, now for example, if it's going to be a bakery, so sometimes every day you might be producing bakery items, different items, fish buns, pastries, and everything, right? So it's like more than one. So conversely, if the batches are large, especially if the products are familiar to the operation, batch process can be fairly repetitive, right? So in a bakery, repetitive activities can be taken. Because of this, a batch type of process can be found over a wide range of volume and variety levels. So variety is also wide, volume would also be wide. Example of batch production includes printers, bakeries, machine shops, education, and furniture making, right? Was it clear? I briefly explained. Yes, right. Okay, then mass processors. Mass processors are those which produce goods in high volume, relatively narrow variety from each. Now, for example, if you take automobile manufacturing shops, it might be Toyota, they might be producing low variety of cars, but from each volume might be high, right? So that is the idea. An automobile plant, for example, might produce several thousands of variants of car if every option of engine size, color, extract, equipment, etc. taken into account. Now, when it comes to, if you can remember, we can use modular design and everything. Chassis, engine, tires, those might be the same. The basic model might be the same. Some small things might be added later. So when it comes to producing the standardized or the modular designs, they can go with this mass production, but at the end, little variations might be done to the end product, right? So yet essentially it is mass operation because of the different variations of its products do not affect the basic process of production. These activities in the automobile plant, like mass operation, are essential, repetitive, and large, predictable, right? Based on the demand of the cars, if the chassis and basic things are the same, they can demand, forecast, and plan stuff accordingly, right? So that is the simple idea. Then we have continuous processes. Continuous processes are one step beyond the mass process.
Madam, excuse me.
Yep.
Yes, madam. Variety, the mass processors, the variety can be increased. Sometimes varieties are not narrow. Sometimes it may be high also, no? Oh, that is a rule
Yes.
inside the mass process.
A variety can be
Narrow, no?
high.
When the high volume, the variety may be high, no?
Normally, the norm is when the volume is high, variety is narrow. it doesn't mean like we don't have differentiated products. Yes, we have some sort of differentiated products. So it might be like now, for example, if it's going to be Toyota products, uh, I can't remember the exact terms. So Corolla might not be that much different from another brand of the same Toyota. I mean, under Toyota brand from another version of car. So if they have like slight variations, the basic things they might be produced in large quantities, the chassis and the engine and everything, and up to certain point assembling also would be done the same. But when it comes to specialized parts, they might be doing that separately. So that is the idea. Was it
Okay.
clear or not clear?
Yeah, yeah. Okay.
When the volume is high, the variation would be reduced. Okay.
Okay, madam. Okay.
Continuous processes, it's like one step beyond the mass production in so much as they operate at even higher volume and often have even lower variety, less variety. They usually operate for a longer period of time. It's like 24/7 operations. Machines hardly shut down. So sometimes they are literally continuous in their products as inseparable being produced in an endless flow. Continuous processes are often associated with relatively inflexible, capital intensive technologies with highly predictable flow, right? So example would be petrochemical refineries, electricity utilities, steel making, some paper making. So when it comes to paper making, if you have visited one of the factories, the basic paper making, they would be continuously doing that. It's like the basic raw material production. Based on that, they might be supplying or that output they might be supplying for some other company. So continuously those machines are operated, right? They hardly stop them actually. So variation is very minimum, and they continuously operate uh, the process, right? So that is the basic idea, right? Was it clear or not clear?
Clear.
Right. Then we come to the process types of service organizations. Now, so far we talked about process types of manufacturing organizations. Those were like project processes, jobbing, batch, mass, and continuous. Right. When it comes to process types, for service organizations, it would be professional services. So, professional services are defined as high contact organizations where customers spend a considerable time in the service process, right? So, that means it's like teaching or consultation, that sort of services, right? So such services provide a high level of customization, the service process being highly adaptable in order to meet individual customer needs, right? A great deal of staff time is spent in front of office. Contact staff are given considerable discretion in servicing customers. So professional services tend to be people based rather than equipment based, that is obvious, with emphasis placed on process, how the service is delivered, rather than the product, what is delivered, right? So when it comes to professional service, if it's going to be uh, a lawyer practices or architect or doctor's surgery, there is a process. So how are we going to conduct this surgery? Where are we going to do that? What are the steps? It might be different from patient to patient. Some patients they might they uh, like They have to be conscious during the operation. Some they can go unconscious, so it depends on the patient's needs. So likewise, based on the customer's needs, the would be very different, and there would be high level of contact as well. Was it clear? Even for the lawyer's practice, individuals requirements, the issues are very different, right? So based on that, the lawyers might be giving the service. Clear?
Clear, madam.
Then the service shops. Service shops are characterized by levels of customer contact, customization, volumes of customers, and staff discretion, which position them between the extremes of professional and the mass services, right? So again, the service shops, they are characterized by the level of contact, customization, and volumes of customer and staff discretion, right? So when it comes to professional services, if you can remember, customization is high level of contact, uh, less number of customers might be served, that sort of things. But when it comes to mass services, right? So if we talk about mass services, mass
Process.
services examples are like supermarkets, national railways network, airport services, or telecommunication services. In those things, less customization. Customization is minimum. A standardized service is provided to each and every person. Limited customer contact, right? But when it comes to service shop, that is in between this professional and the mass services, it's like some sort of customer contact is there, customization, some sort of customization is there, not fully customized. And volume, it might be average volume. So that sort of things are there, right? Okay, so that is the idea. Then services provided via mixes of front and back office activities, right? So when it comes to a bank, now examples are banks, high street shops, holiday tour operators, car rental companies, schools, most restaurants, hotels, and travel agencies. In restaurants, we have back office. Even in banks, we have back office, right? So back office activities are there. Rather than dealing with the customers, back office activities are there, right? So for example, an equipment hire and sale organization may have a range of products displayed in front office outlets, while back office operations look after purchasing and administration, right? So hire and sales, equipment hire and sales organizations, yes, they have to display, they have to sell whatever the products. It might be some uh, basic items or equipment that are used for construction, maybe. But even though they display those things and they hire, or sometimes they might be selling, they might be engaging in both. Yes, they have to ensure once the products are sold, they have to fill them. For that, at the back end, there might be administration staff or purchasing staff. They are engaging in purchasing and those activities, right? So the front of staff have some technical training, can advise customer during the process of selling the product. Essentially, the customer is buying fairly standardized product, but will be influenced by the process of sale, which is customized to their individual needs, right? So sometimes based on the customer needs, little customization will be possible. For example, for the bank, sometimes if a person needs an urgent thing to be a thing get a thing to get I mean a certain service, if that person, now imagine if it's going to be a loan, right? Normally a bank would say, right, to grant a loan or to pass the approval for this particular loan, it will take like 2 days. But if a person says, no, I'm sorry, I need, this is very urgent for me, can I get it done within 1 day? So sometimes based on that requirement, little discussions among the management, that service might be provided, right? So that is the idea. Was it clear?
Yes, madam.
Right. Then I talked about the mass services. They are like little customer interaction or less customization. A standardized service is provided actually, right? So that is the idea. So staff, when it comes to staff, they do not have to do their, most of them, they do not have to make their own decisions or less flexibility. They have to do whatever the task they are assigned to do because they are providing a standardized service. But when it comes to professional or the service shops, some sort of customization is there even in service shops. So the service provider or the employees within the service organization, they have some sort of flexibility. They can make their own decisions based on the customer's requirement. But here it is not necessary, right? Right. Okay, then we are going to talk about uh, detailed process design. Or when it comes to process design, we have to map it to have an understanding about the process. So process mapping simply involves describing processes in terms of how the activities within the process relate to each other, right? So process mapping symbols are used to classify different types of activity. Although there is no universal set of symbols used all over the world for any type of processes, there are some that are commonly used, right? So simply when it comes to processors or detailed process design, we can use these symbols, right? So this circle is for the operation, this is for inspection, this is for transport, this is for delay, this is for storage, this is for if it is going to be a process, we have the start and the end. So to symbolize that, we can use this shape activity for this. So likewise, some sort of commonly accepted symbols are there. Using them, you can map the process. That is the idea. Was it clear?
Yes, madam.
Yes, madam.
Right. So now here in this one, you can see uh, a detailed process or process map, right? So this is for a standard sandwich process. So this triangle was symbolized for the storage, right? So from the raw material storage, they might be taking some items and uh, assemble. It might be the bread and the ingredients. Using them, they might be making the sandwich. Then the sandwich might be stored or finished good might be stored. Then it would be moved to the store or outlet, right? So if it is going to be Pereira and Sons kitchen, from the raw material store, they might be taking items and assemble them. Then they will be stored that they mean maybe in the kitchen, maybe it depends, right? Then from the kitchen, they are moved to the outlet. In the outlet, in a showcase, they are stored. Then uh, here this is an activity based on the customer's requirement. They might be selling and they might be taking the payment, right? So this might be a standardized service, right? So but when it comes to customized sandwich old process, here they have shown an old process. So based on the customer requirement, they might be taking raw material and make the sandwich, assemble, then take the payment. So that means once the customer request only, they start manufacturing or processing it, something like that, right? But when it comes to the new process, they have developed this process. So they have mentioned, right, bread and base filling is stored, or that is there, right? uh, so So assembly of the sandwich bases, it might be like when it comes to a sandwich, it might be having different fillings. So they might be talking about that. So based on the customer's request, different bases might be made and stored, right? Then uh, based on the customer's requirement, right? You now, is it clear up to this point? They might be having bread and the base. Different bases might be stored, right? Okay, bread is available. Now, based on the customer's requirement, customer might be requesting a normal standardized sandwich or customized sandwich or a different sandwich, right? So if it is a standardized sandwich, then assemble the whole sandwich, maybe using the standardized filling, right? But if it is going to be a customized request, right? So for the base, they might be doing certain differences, and based on that, uh, sandwich will be assembled and given to the customer. So simply, this might be quite complex. So I will be, because we don't know the behind the story, so simply what is shown is, if a customer's request is a standardized request, we have a different process in the same process. If it's going to be a unique request, we have a different process, right? So that is the idea, right? Clear? Or else you can think about this like that. Bread and base filling, those things might be differently kept here, right? uh, Here for the different bases based on the customer requirements might be produced and kept, right? Here sometimes we might be having bread aside as well. So based on the customer's requirement, if it is a standardized one, normal process will be followed. If it is going to be a different one, different process would be followed, something like that. Clear?
Yes,
Clear or
ma'am.
not? Yeah. Then at a slightly lower or more detailed level, identifies the sequence of activities, right? So one significant advantage of mapping processes is that each activity can be systematically changed in an attempt to improve the process. So at a slightly lower or more detailed level, identify the sequence of activities. One significant advantage of mapping process is that each activity can be systematically challenged in an attempt to improve the process, right? So sometimes by looking at this, you can see, like we discussed about the service blueprint, you can identify maybe failure points, or if even if they don't have any failure points, if you want to further improve the process, you can improve it, right? uh, so an aggregated process map that shows broad activities rather than detailed activities, sometimes called an outline process map. Now I will show you that. Now here, if you have like, you might be having, or even I had the question, now what do you mean by this assembly of sandwich base? What do you mean by this filling? What do you mean by stored base, right? So here the detail is not visible, right? So that might be confusing, and if you want to improve the process, you have to look into that detailed process as well, right? Then it will be more clearer, right? Here, something like that, assembly as required. So what do you mean by that? They have further explained that. If you want, you can further explain assemble from the standard base. What do you mean by that? If you want, you can further explain it, right? So likewise, uh, you have to go in detail. If not, you can't have a clear picture about the process, and based on that, you can't improve. Okay. We have to finish the lecture at 12. 12, right?
Yes, ma'am.
Okay,
Uh,
madam.
I thought it's at 11:30 today. Sorry. Right. Okay. Now, when it comes to this process design, uh, when you are going to map a process, based on that, if you want to improve the process, you can have an idea about different activities and whether to decide, are you going to have one server or many servers. So likewise, based on the calculations, you can think, are we going to rely on the existing process, or are we going to change it based on the findings that we found or something like that, right? So for that, you have to do certain calculations, right? So we will be talking about them, right? So the first thing is work content, right? So the work content is the total amount of work required to produce a unit of output, usually measured in standard times, right? So now here again we have throughput time. Throughput time is the time for a unit to move through a process, right? So if you go to a shop, right? If you go to a shop, from the time you enter the shop and the time you go out from the shop, it can be considered as the throughput time. But the work content is it's like total amount of work required to produce a unit of output. It's like uh, here if I give you like the amount of time that would take to produce a sandwich or something like that, right? So all the new process can be done to move some of work to a less busy time. So the work content, the total amount of work required to produce a unit of output, has not changed, but customer throughput time, the time for a unit to move through the process, has improved, right? So that means, okay, now throughput time means it includes actually waiting time and the being served time, right? So if you want to improve your process, you can reduce the waiting time or the throughput time. Sometimes work content, the amount of work that you are going to do now, if it is going to be a salon, customers, now if it is going to be a salon, whatever the service that you are providing, it would take certain time. So that work amount will not be changed. But if you want to improve the service. On the other hand side, you can reduce the waiting time, right? So that might be uh, done doing certain things, right? Certain activities, maybe change in the layout or any other things. For example, suppose that the time to assemble and sell a sandwich, the work content using all process was 2 minutes. Right now, here customers are coming to purchase sandwiches. That is the work content, right? So once they order, they assemble. If it is a standard one, for that it will take 2 minutes. That two people were staff in the process during the busy period, right? Each person could serve a customer every 2 minutes. Therefore, every 2 minutes, two customers were being served. On average, a customer was emerging from the process every minute. Right? So that is clear, right? Now, if a customer comes to purchase a sandwich, to produce a sandwich, it will take 2 minutes, right? And they have two people, person one, person two, right? So now uh, to this particular shop, okay, to this particular shop, a person could serve a customer every 2 minutes. Therefore, every 2 minutes, two customers were being served. So on average, a customer was emerging from the process every minute, right? That means if two customers entered to the customer, both will be served within 2 minutes. That is the idea, because there are two servers, right? Two people are there who will produce the sandwiches. So one person spends 2 minutes. So parallelly, both of them within 2 minutes, they produce two sandwiches and two customers are served. So if you take uh, or if you do further calculations, right? Altogether, within 1 minute, one customer is served. That is the idea. Because, right, here altogether we have 4 minutes. It's like 4 divided by 2. No. No. Every customer is served within 1 minute. Yeah. So because in every 2 minutes, two customers are entered and we served two of them. So that means simply, if we convert that to 1 minute, within 1 minute, one customer is served. 2 minutes divided by two customers, something like that. Clear? So this is called the cycle time of the process. The average time between units of output emerging from the process. Now this is important, right? The average time between unit of service the average time between units of outputs emerging from the process, right? So that means like here, in every 2 minutes, two customers are served. In every 2 minutes, two customers are served. So to serve one customer, how long will it take, right? So that is the idea. So that is the average time between units of output emerging from the process, right? So when the customer joins the queue in the process, they become work in process or work in progress, sometimes written as WIP. If the queue is 10 people long, including the customer, when the customer joins it, he or she will have to wait 10 minutes to emerge from the process, or put more succinctly, right? So now here the most important things that you have to understand is, Work content. Work content means total amount of work required to produce a unit of output, right? So if a customer is coming to purchase a sandwich, how long will it take to produce a sandwich? That is it. If a person is coming to get a car service, to service the car, how long will it take? That is the work content. Clear? Then the throughput time means it is like once you enter the shop and once you have purchased whatever the item or got the service that you expected to get from the organization, and from the point of you entered and the up to the point that you leave the shop, that is the throughput time, right? So the time of a unit to move through a process. Okay, then the cycle time, that is now as the customer, on average how long will it take to serve a customer, right? So that is the cycle time, the average time between units of output emerging from the process, right? So that is the idea. Then the work in process or work in progress means the waiting time. Now when you enter a shop, if you have to wait for 10 minutes and within 2 minutes you got the sandwich, 10 minutes waiting time is the working process. Clear? Is it clear?
Yes, ma'am.
So here, when it comes to throughput time, right, or the entire time that you spend in the shop, that can be calculated using work in process into cycle time, right? Work in process into cycle time. Then to calculate the mathematical relationship between the throughput time, working process, and cycle time, we can use this Little's law. Little might be the person who identified this, so that might be the reason this is called as Little's law. I'm not so sure about that. So, for example, suppose it is decided that when the new process is introduced, the average number of customers in the process should be limited to around 10, right? Average number of customers in the process should be limited to around 10. Maximum time a customer is in the process should be on average 4 minutes, right? If the time to assemble and sell a sandwich from the customer request to customer leaving process in the new process has 1.12 minutes. So this is the work content, right? This is the work content. First, by looking at the question, you have to identify what these things are, right? So the work content is 1.2 minutes. Can you see the screen? Yeah. Then the maximum time a customer is in the process should be on average 4 minutes. That is the throughput time. 4 minutes, right? The average number of customers in the process should be limited to around 10. It is like the work in process, right? That means who are waiting in the system, it should be 10. Okay. Now, based on this, you are asked to calculate the number of how many staff should be serving, right? So we'll see how to do that. So how to calculate the throughput time? Work in progress into cycle time. Right. So here throughput time is 4 minutes. Work in progress is 10. We don't know the cycle time, right? So if you found the cycle time is throughput time divided by the working progress time. Then cycle time would be 0.4, right? That is like within 0.4 minutes, every customer would be served or something like that, right? Now, although the organization's intention is to serve a customer in every it's like 0.4 minutes, right? Now if you can remember in the previous example also, they use 2 employees to produce sandwiches. So every 2 minutes 2 people are producing sandwiches, and every 2 minutes 2 customers are served. So on average in 1 minute 1 customer is served. Likewise, in this case, right, they normally take to produce a sandwich, it takes 1.2 minutes. It is not changed, it is the same, right? 1.2 minutes it will take to produce the sandwich. Work content is the same, but how are we going to ensure throughout the system? Now this might not be visibly seeing like every 0.4 minute we are serving a customer. We won't be seeing that. When we are having servers or different number of servers or the service providers, we might be seeing, yes, in every 1.2 minutes, if we have 5 servers, 5 customers are served. But using that, we will see, okay, our cycle time will be reduced, or on average per minute, or how long, or else we will consider to serve one customer on average how long will it take. So that is the idea behind this cycle time, right? But even though the cycle time is like this, how we got this cycle time, right? How we got this cycle time, that is change in the process. It might be enhancing the servers. That is the idea behind this. Now if you want to know, like, even though every 0.4 minute we are like serving a customer, we have to, or it takes 1.2 minutes to produce a sandwich. Therefore, by dividing 1.2 or the work content by the cycle time, we can identify number of servers that we want, right? That means we have server 1 here, server 2 here, server 3 here. So in every 1.2 minute, right, customers are coming. C1 is served, C2 is served, C3 is served parallelly. Clear? these people are served parallelly, right? So simply, if we divide 1.2 by 3, I think that will also give us the cycle time. Yep, got it?
Yes, ma'am.
Yeah. So that is how we calculate this. Okay. It doesn't say like we are serving like every customer at 0.4, but we have minimized this time as a system, the time that we spend to serve a customer on average, right? So that is the idea. If not, if we had one server, cycle time would be 1.2, right? So our system will not be very productive, right? So within 1 hour, we might be serving less number of customers. For example, within 1 hour, we might be catering around 0.83 customers. But if we have like 0.4 cycle time, we might be serving 2.5 customers, something like that. Okay, so this is the idea. Clear?
Yes, ma'am.
Then you have another one. I'm sorry, I'm not sure. Right. Here, every year it was the same. Now, this is a separate question, right? Every year it was the same. All the workstations in the building had to be renovated. That means tested, new software installed, or certain activities. There was only 1 week in which to do it, right? The 1 week fell in the middle of the August vacation period when the renovation process would cause minimum disruption to normal working, right? So that part is not essential. Then let's focus on these. Last year, the company's 500 workstation had all been renovated within 1 week, right? So 500 workstations they have renovated within 1 week, that is equal to 40 hours, right? 500, not one, all the 500, right? Each renovation last year took on average 2 hours, right? Each renovation it took on average 2 hours, and 25 technicians had completed the process within the work, right? So that is the last year information. So this year there would be 530 workstations to renovate, but the company's IT support unit had advised faster testing and the renovation routine that would only take on average 1.5 hours instead of 2 hours. How many technicians will be needed this year to complete the renovation process within this work? Right. So I think I have copied this on Excel. No. Try to do this. Did you give it a try? Okay. This is the question, right? When it comes to this little slow, okay. Now, to calculate the throughput time, you can use either work in progress into cycle time. If not, according to this little slow, you can use throughput time can be calculated as work in progress divided by throughput rate, right? Work in progress divided by throughput rate. We'll write it here. Okay, so what do you mean by the throughput rate? That is actually throughput rate means all the time 1 divided by the flow time or time taken to or work content, right? 1 divided by, you can say it as work content, right? How long will it take to produce a certain thing or something like that, right? Was it clear? Again, according to little slow, we can calculate throughput time, work in progress divided by throughput rate. Now we know what is work in progress, throughput time, but we don't know what is throughput rate. Throughput rate is equal to 1 divided by work content, right? So when it comes to our question, right, here or else you can simply without considering all those things, you can simply calculate this one, right? Now the question is, each renovation last year took on average 2 hours. 25 technicians had completed the process within the week. This year there would be 530 workstations to renovate, but the company so IT support unit had devised the fastest testing and renovation routine that would only take on average 1.5 hours instead of 2 hours. How many technicians will be needed this year to complete the renovation, right? So if you look at the previous year, right? In the previous year, they had to produce 500 works or repair 500 workstations, and they took 100 hours, because 500 workstations to do one, it took 2 hours. So 100 hours they have spent, right? So if you look at the available time per week, that is 40, and available time is 40. Yeah, available time is 40, right? Now, yeah, without having that also we can do that. Available time is 40. Now they have only this many hours, 40 hours, right? If they use only one person to produce these 500 workstations, spending 2 hours on that, right? Within 1 week, we can't do that, right? That means actually we can't do it. Okay, so how to do that? How to explain it? I'm thinking of that. Now, yeah, this is the thing. They have only 40 hours per week, but they need 1,000 hours. If you use one worker or one technician, you can't complete everything, right? So 40 divided by 2, because to produce one it takes 2, maybe you would be able to complete 20 only, right? Therefore, what you are going to do, total required time divided by the available time, then you know if you have 25 people you can do this. That is the idea. So that is the logic, simple logic actually, right? Now here again I'm saying, to produce 500 workstations they have to spend 2 hours per unit. I mean, if they have one workstation they have to spend 2 hours, right? So then when they have 500 into 2, that means they need 1,000 hours. But if they have only one technician, they have got only 40 hours. So we spending 40 hours, they can't complete these 500. Therefore they think, okay, if one person has to spend 40 hours on this activity, right? If we divide this 1,000 by one person's available time, then we think, okay, if you use 25 workers, we can complete this. That is the idea. Is it clear? Or not clear?
Clear, ma'am.
Right. So thinking like that, how are we going to do the other one? This, to produce 530, they need 530 into 1.5 hours, 795, right? So if they use one person, they have got 40, so they can't do it because they need 700 more time, 700 plus time. So they have to use more workers. It's 19.87, so you can round that up to 20. So that is how you can calculate it. Clear? If not, this is one way. If not, based on the throughput time, the little slow, right? It is, I told you that work in progress divided by throughput rate, right? So here the work in progress is 500, right? Throughput rate is 1 divided by the work content. So throughput rate, that is actually given per technician, right? Throughput rate is, it's like, I would say it's like throughput rate means 1 divided by the work content. That means per worker or per server, we present that throughput rate per worker or per server, right? So 1 divided by work content n, right? So here it would be the same. Right, so the throughput time is, it's like how long will one unit be in the process. It's like available time is 40, right? It's equal to available time, right? So last year company 500 workstation had all been renovated within 1 working week, right? So we assume that is 40. So based on that, now we can identify the number of technicians. If this is complex, just forget it, right? So then this becomes 0.5n. This is 40, right? So 40 into, we can multiply it, 0.5. On this side we have 5. Yeah. This method can also be followed. For the previous question, we got the same answer. For this one also, we will be getting 20 as the answer, right? So that is one way. Was it clear or not clear? The previous one is clear. Please tell me if it's not clear. Clear or not clear?
Clear, madam.
Right. Then we are talking something called throughput efficiency, throughput time of a process, or the time that a unit is in the system is different from the work content of whatever it is processing, has important implications, right? So what it means is that for a significant amount of time, no useful work is being done to the material information of customers that are progressing through the process, right? That means, now you know, if even though the customer spends 4 minutes in the system, it includes waiting time, but actually the being served is the work content time. Therefore, using that ratio, you can calculate the throughput efficiency, right? So throughput efficiency means throughput time, work content divided by the throughput time, right? So here 1.2 is the work content, 4 is the in the previous sandwich example. 4, the answer is equal to 30%. Then a vehicle licensing center receives application documents, keys in details, checks the information provided on the application, classifies the application according to the type of license required, confirms payment, then issues mails the license, right? It is currently processing average 500 license every 8 hours. A recent spot check found 15,000 applications that were in progress or waiting to be processed. The sum of all activities required to process an application is 25 minutes. What is the throughput efficiency of the process, right? So you have to find it, right? Now, what is the throughput time? First, you have to find the throughput time. Here, throughput time is not given, right? So they have given us a hint. So to calculate the throughput time, you can use two formulas. I told you. So here we can use cycle time into work in progress, right? So work in progress is given 15,000 application, right? So work content is also given, and the currently processing average 500 license every 8-hour day, right? So every 8-hour day in total they produce 500 license. Therefore you want to know to process one license, how long will it take? That can be considered as the cycle time, right? So 8 hours, you can, this shouldn't be 515,000, this should be 500. 8 hours, they have converted this into minutes. 480 divided by 5,000, that is this many minutes. That is the cycle time. So cycle time multiplied by the work in progress, you will get the throughput time, right? So the throughput time is 1,440 minutes, right? So they have further done this, but let's focus on the minutes. Then the efficiency is the work content, that is also given in minutes, right? Work content is 25, that is divided by the throughput time 1,440, that is 1.74% is the work efficiency time or throughput efficiency time. Is it clear?
Yes, ma'am.
Yes.
Right. Then there is another thing, right? So value added throughput efficiency. Now throughput efficiency is the same here. Value added. So there we have to focus only on work content, right? The approach to calculating throughput efficiency that is described about assume that all the work content is actually needed, right? So we assume every activity is needed. So value added throughput efficiency restrict the concept of work content to only those tasks that are literally adding value to whatever is being processed. This often eliminates activities such as movements, delays, and some inspections, right? So when it comes to processing a sandwich, we have movements, we have wait times or delays. All those things might be included in the work content time. But if you disregard those delays, movements, and inspection, then you will get value added work content. Now in this example, work content is 25, 5 minutes are with non-value adding activities, right? Therefore the value added work content is 25 minutes minus 5 minutes, that is equal to 20. Then if you want to calculate the value added throughput time, that is value added work content, which is 20 divided by the throughput time 1,440. Is it clear?
Yes, ma'am.
Right. So there's another example. I think, yeah, I talked about the same thing, right? Sorry. Right. Then we are going to focus about on the break-even analysis, right? So now we might be having, when it comes to processes, we might be having different processes that might be in line with the production or the service. So out of those processes or the machines, we have to pick the most the process that might be economically benefit or something like that. So for that, we can conduct a break-even analysis, right? A standard approach to choosing among alternative processes or equipment. Model seeks to determine the point in unit processed or sold where we will start making process on the process or equipment, right? So simply, when it comes to break-even point, that means at the break-even point, actually, we are making zero profit. Our total. Now, initially, when it comes to a process, we have to incur fixed cost. That is the cost of machines. It might be the cost of electricity. Uh, some sort of fixed cost are there, right? So we have fixed costs as well as we have variable cost, right? So per unit raw material cost, per unit labor cost, that sort of costs are also there, right? So when it comes to this total cost, uh, when it comes to these total costs, we have to like as organizations, actually we are like how can I call it, tell it, when it comes to organizations, right? Once you have started the process newly, you have to check, is it profitable to do this job or produce this product or deliver this service. So you have to do an analysis. You check, okay, covering all the fixed costs that I incurred and covering variable costs, at which point am I going to make profits? It's like, if it is going to be a manufacturing organization, there you are going to manufacture vehicles, right? So if I manufacture 1,000 vehicles, am I going to be profitable? So for that, you might be making an analysis, right? So when you are doing that sort of an analysis at different quantities of the products that you are going to manufacture, this is at the planning stage, you will find a point where your total cost, which includes uh, fixed cost and the variable cost, is equal to your revenue. That is the point called break even point. Upon the break even point or above the break even point, whatever the units that you are producing, you will be gaining profits. So that is the simple idea behind this break even point, right? So at the break even point, your total revenue is equal to total cost. So cost includes fixed costs and the variable costs. Okay. What do you mean by the revenue? Revenue is equals to unit price or unit price into number of units that you sell. Is it clear? Is it clear or not clear?
Madam, can you explain again 47 slide?
Yeah. So why do we now, when it comes to business organizations, yes, we have a plan to produce a product or deliver a service, right? So even though you think to produce a product or deliver a service, you have to do some sort of an economic analysis. As I told you, if you can remember, I told you that we can do feasibility studies. There we might be doing economic analysis. So when it comes to that economic analysis, out of different processes that we plan to produce our product or deliver a service, uh, we have to think whether this is worth doing, right? If you are not going to make profits, no point of uh, doing that, producing a product or delivering a service. Therefore, maybe you might be considering your forecast or demand and the cost that you have to incur. You might be doing a break even analysis, right? When you are doing that break even analysis, what you have to do, uh, right, at the break in the break even analysis, what we do is we have to find a break even point, right? So the break even point is the point where your total revenue is equal to total cost, sorry, equal to total cost, right? So I can't type it here. So here this should be equal to total cost, right? So simply what does this mean? If you have incurred in total say 4,000, right, your revenue is 2,000. So what is the profit? How to calculate the profit? Profit is revenue minus the cost, right? So it is minus 2,000. That means you are making a loss. So you further check, right? If I increase the revenue uh, up to maybe 4,000, then still my cost would be 4,000. Then I'm not making either a profit or a loss. So this is known as a break even point. Okay. So when you further increase your revenue, it depends here. You assume the cost will be fixed. But that is not the practical situation. I'm just explaining. If you further enhance the revenue, right, then now you will be gaining a profit. Revenue 4,500 minus the total cost 500. So after that, what is the idea? This is the break even point. Before the break even point, you are making losses. After the break even point, you are making profit, right? So now by this analysis, what you have to do, you have to see, do we have sufficient demand to gain profits? That means now, if I explain this further, when it comes to revenue, how are we going to calculate the revenue? Price into the quantity sold or the demand. It will say quantity, right? So if our price is, let's say 20, price is 20, right? Now here revenue, quantity, right? If the price is 20, the quantity is 100, the revenue is 200, right? So price would not change, it would be the same. If you enhance the quantity by 100 and up to 150, then your revenue would be 3000. If you further enhance it, the revenue would be 4000. So at this, when you are selling 200 units only, you will be reaching the break even point. If you further enhance your selling quantity, say 250, your revenue will be 5000. You are enhancing or you are gaining a profit, right? So that is the idea behind this break even point. And from your perspective, you have to see whether you have sufficient demand to make profit, whether you have 200 demand or above that. It's better if you have 200 and above quantity, 200 and above. Slightly having 200, it does not make any difference. You might be covering your cost by selling the products or by catering to the market available demand. But if you have above this break even demand or break even quantity, yes, you will be making profits. Is it clear or not clear?
Yes, madam, clear.
Right. Now here, oh sorry. Here, you are given a question. Suppose you want to purchase a new computer that will cost 5000. It will be used to process written orders for customers who will pay 25 each for the service. The cost of labor, electricity, and the form used to place the order is 500 per customer. How many customers will we need to serve to permit the total revenue to break even with our costs, right? Now, if you can remember in the previous Excel sheet, I told you that we should identify the break even quantity, the break even demand, right? So to identify the break even quantity, you do not have to do that sort of analysis. First, what you have to do is there is a formula that you can identify the break even demand, right? So that is known as the total cost or break even demand is equal to total fixed cost divided by per unit price minus per unit variable cost, right? So here it is mentioned total fixed cost divided by unit price to customer and the variable cost, right? Here the fixed cost. Fixed cost are the cost, uh, those are like the huge costs that are not spent per unit basis, right? For example, if you are going to serve a customer, if you are going to hire a server or a person, yes, that person is hired to cater that particular customer. And if you are going to process a sandwich for the customer, yes, for the customer, per unit raw material cost might be there. But you produce all those things under one building, under one roof. For that, you might have purchased a land or rent out a certain place. For that, there might be a rental price, right? Every month you might have to pay, or I don't know, it depends on the thing that you do. And also you might have purchased machines, right? Machines are not per unit basis utilized, right? So many items are produced, it might be at the same time, right? So for that sort of I would say the capital intensive cost would be considered under this fixed cost. Right now here you are given uh, Suppose as an organization you are supposed to purchase a new computer that will cost 5,000. So a computer, this is used to serve the customer. So this is a fixed cost here, 5,000, right? Then it will be used to process written orders for customers who will pay 25 each for the service, right? So customers will pay for this service $25, right? So that is like the price that the customers are paying for your organization. Then the cost of labor, electricity, the form used to place the order is $5 per customer. That is the variable cost. Variable cost is the cost that is I mean per unit cost, or I mean we can calculate it for each unit separately. It's not like a fixed cost. So fixed cost that might be running for years maybe, but when it comes to this variable cost, those are like unit basis, right? So the cost of labor, electricity, the form used to place the order is $5 per customer. That is the variable cost. So using that formula now you can find the break even demand. It's like the total fixed cost 5,000 divided by 25 minus 5, that is 250 customers. Is it clear, or you want me to explain more about fixed cost and the variable cost? Please tell me.
Madam, could you repeat again fixed cost and variable cost?
Right. Uh, then I'll prepare a separate slide for that. Give me 1 second. Then it will be clear for you. Okay. Okay. Fixed cost, the definition is costs that do not change with the level of production or the sales, right? So this remains constant regardless of whether the company produces a lot of or little or nothing at all, right? Rent. Now, if you have purchased a land or a place to for your service, so as you plan for the very first day, you could not, or for the now you plan to start up your the production in January, but unfortunately, due to unavoidable situation, you cannot start that in January. So you shift to February. But in January, although you did not produce anything, you have to pay that particular month's rent. So that doesn't change with the level of production. Now, even though you increase the production or decrease the production or no production, rent should be paid. Salaries of the permanent staff, that is also the same. Even though, even if it is a season where you don't have any orders, you have to pay salaries for the permanent staff, right? So those are the fixed costs, right? That doesn't change with the production or the sales. Clear? Is that part clear?
Yes, madam.
Then the variable cost, it is the cost that change directly with the level of production or the sale. The more you produce, the higher the variable cost. If you produce nothing, variable cost is zero. For example, if you want to produce buns or the sandwiches, you have to purchase bread, tuna, or whatever the ingredients. When the quantity is high, that cost is higher. When the quantity is low, that cost is low. If you don't produce anything, that cost is zero. Then this total variable cost or raw material, direct labor, packaging, everything is uh, added together and divided among the number of products produced or sold. Then you will get variable cost per unit, right? So that is the idea. Clear? So that is
Yes.
how yeah, for the break-even demand, total fixed cost should be considered, per unit price should be considered, per unit variable should be considered, right? Forget about the contribution. So here also they have purchased the computer for their this service, right? So and using that computer, they are going to write orders used to process written orders from customers who will pay $25 each of the service, right? For this particular service, they have purchased this computer. So even though you do not provide the service or provide, you have to bear, you have already uh, spent on that, right? So that is a fixed cost. Here the customer is giving $25 and electricity and everything, that is the variable cost. So based on that, you have to calculate the break even demand, right? Here 250 customers, or you, if you want to uh, cover your initial cost, that means the total fixed cost, you have to cater 250 customers. If you want to enhance the profit about that, or if you want to, now at this 250, no profit or no loss, you have covered the fixed cost as well as the variable cost up to that point, because variable cost is associated with the amount that you produce or sell, right? So if you want to now, after 250 customers, you can make profits, right? Because you have covered the fixed cost that you have spent. Is it clear? For example, you can take, like, imagine you are going to cater 300 customers, right? 300 is the quantity and the unit price is 25, cost is 5, right? So revenue would be 300 into 25. 300 multiplied by 25, how much would that be? 7,500, right? So the cost would be 300 into, now this is a variable cost, right? $5. So 300 into 5, 1,500. Then the profit is revenue minus cost. So that is 7,500 minus 1,500. So what is the profit? 6,000. Clear?